let's start this. I want to introduce some regular expressions to you. So I have a quick overview on what regular expressions and I are. I'm then trying to give you the building blocks of regular expressions and then dive into some examples and even do some demos, let's call them. So who am I? I'm age 33. I'm Diplom-Informatiker. I started programming like in the 90s. I had my first contact with regular expressions through PHP and MySQL probably around 2000. Currently, I'm employed as a software developer with focus on T-SQL. I'm also doing C# and PowerShell for the Rosen Group currently. I have experience in a lot of different languages. And also, I have this nice MCSA certificate that will be probably invalid next year or so. Yeah, let's see about that. On the other hand, what's regular expressions? It's like SQL, you have some POSIX standard behind it, but in the end, nobody really is using it. Also, the POSIX standard defines 3 flavors, one of which is deprecated already. So I'm mostly focusing today on regular expressions that follow this Perl-compatible regular expression style, which similar to the extended regular expressions for all I know. Most of the stuff I will be showing you is applicable to all the regular expressions I'm currently aware of. Like obviously, if you're using old versions, that might not all be implemented, but if you're using recent versions, it should all be going fine. If I know that things aren't working everywhere, I try to put this little dagger to the note of what I'll show you. So to remind me and you that this might or might not work for your scenario. So what can I do with regular expressions? So in the end, there are mathematical roots behind this. I can follow, I think, a context-free grammar with the regular expression. You can probably look it up. It's usually not that useful to know that, but sometimes if you're doing science, it might help you still. You have a very common problem that's tackled as searching for strings or searching inside strings, and you probably need more than a literal match, and well, you don't want to write a dedicated parser still, so you can use regular expressions. But at the end, if you have a flexible tool, you usually also pay for it. So regular expressions are not indexable usually and stuff like that. It will chew some CPU, but usually it's okay. And then in the end, obviously, it's okay for many things, but not for everything. Regular expressions themselves are composed of some, let's call them building blocks, some very basic concepts that repeat themselves over and over. So we have literals, we have classes, we have quantifiers, we have groups, and we have anchors and asserts that, well, serve a bit of the same purpose. We'll try to give you a quick introduction to all of those building blocks before going into well, examples on how we can put them to use. So the probably simplest class is literals. So most characters, except those that I will cover on the next slides, are just matching themselves. So they are literals. If I need to escape something because it would have a special meaning otherwise, I put a backslash in front of it, just like I would do in JSON or C. And I also can use some of the escapes that are common to JSON and C, like for example, \r or \n or \t are carriage, return, line feed, or tab. More interesting is character classes. Character classes work a bit similar to what you probably know from T-SQL's like. So the basic form is that you have those brackets, you write all the characters you want to match in between, and well, then you match one of those at this point of the pattern. I should probably emphasize right now that you have to match every character that is encountered from the beginning of your match. So yeah, this probably not a surprise, but useful to know. And if you want to do character classes, often it's more easy to write ranges, or you may even might have easier time to write an inverted session. Like with this hat. This is still what you can do with T-SQL's like. What is a bit different from the like is that the dot is the character to match anything, while anything usually means no line breaks, but usually also there's an option to toggle whether the dot matches line breaks or not. \d matches digits. So this is the first predefined character class I want to introduce to you. Here you only have one backslash and one d. So this is how predefined classes are introduced. The dagger reminds me that this might be Unicode digits matched. So while I usually use the English digits or the digits commonly used with English language, you have digits in Arabic or Chinese language that might be matched with D as well. So if you're sure you don't want to match them, maybe it's easier to write a character class that just matches what you match. \w is one of my favorite classes. It means word letters, but word letters here is defined as Perl identifier compatible letters. So it usually is something like alphanumeric letters and an underscore, which is fine enough if you want to find identifiers. \s matches whitespace, so carriage return, tabs, space, whatever. Also very useful. And a very useful thing that applies to all of those predefined classes is that if you uppercase the class, it will get inverted. So \uppercase s matches non-whitespace, so everything that \s wouldn't match. In the end, you can combine those. So I can say, okay, I want to extend those \d and add a to f to match hex digits. And again, be reminded that \d probably also matches digits that I'm not so well aware of. And otherwise, I would really want to direct you to the documentation of your very implementation, because usually there are more predefined classes. For example, for Unicode classes, or stuff like that. There are many different classes that are often predefined. So with classes out of the way, we have quantifiers. So this is something that I really miss in T-SQLs like. So I may or may not have a certain character because I don't know. You don't always have a decimal digit, for example, in your input, but it could be, and it would be perfectly valid. So I can just put a question mark after a class or a literal or whatever and have it match or not match once. I could also do a plus to have it match at least once, or have a star to match it from 0 to any number of times. So very handsome to have, don't know, matching numbers of variable length or whatsoever. And also I can do numeric ranges. So the fourth case here says I have 0 or 1, like this one, but it could also write I have 0, 4 or whatever. So I would have 0, 1, 2, 3, or 4 times this A inside my string. Or I can say I need at least 2, then I would write 2, or I say I don't want to repeat whatever I've written here, but I want to have this 3 times. Like, don't know, for example, in dates, you probably have like a year with 4 digits, so you can write a 4 in square brackets if you, in curly brackets if you want to. There are some modifiers here. So if you write a question mark after a quantifier, it will act as a non-greedy quantifier. So usually the default is that a quantifier will try to match as much as it can. So if I'm writing A+, it will match all the A's there are. And if the next thing in my pattern doesn't match, it will try to release one A, try to see if it matches then, release another A, try to see if it matches then. And if I know that usually I want to have the shortest sequence applicable and then check if the next thing matches, it is a good thing to write the question mark after it. And then there's the other way around where I say, okay, I'm writing a plus to the end of my quantifier. So it will hack all the A's and it will not give any back. So if the thing after in my pattern doesn't match, there is no match. We start the process from the beginning over. Well, it's nice to have quantifiers and literals and character classes, but in the end, much of the power comes from groups. So one of the things that I really like is that you can match parts. For example, if I want to match date, I can define 3 groups, one which matches the year, one which matches the day, and one which matches the month, and just have them available as group results to use them afterwards. So it's one match, I immediately have all that I want to, and I just need to convert it to numbers. So it's a really nice way. You can later refer to them. It's a bit, well, not so handy that there are two different styles. Like in the pattern, it's backslash, and outside the pattern and replacements, it's usually $sign in front. So this would match an A with either single or double quotes, and it will ensure that the same quotation is used on both ends of the A, which is the common case if you use quotation. You can use named groups as well. So I named this group here Q for quote. But then again, referring to named groups is a lot less standardized than defining them, and even defining them isn't supported by any dialect. So this is seemingly the most common form of referring to them, but watch out, it might or might not work. Also, I probably would also only do this for regular expressions that you save somewhere, because it usually means you're writing a bit more. Groups allow you to have alternatives. Alternatives themselves are introduced just by the pipe. You don't need a group for this. But if you don't have a group, then the full regular expression has an alternative now. So usually when you're doing alternatives, you're doing it inside groups. You can have this question mark at the beginning of the group and a colon, and this will make a group non-capturing. So if you want to later change your extended expression, for example, a regular expression, for example, and introduce another group for whatever reason, but don't want to rewrite your replacement strings, this might be a way to introduce further groups. Or if you're really not interested in capturing anything at all. You can change options. Options are obviously implementation specific. I is usually supported, which means case sensitive or not. You can switch this just for the group or for everything following the group, depending on what works better for you. And obviously you can combine groups with things that we learned before. So for example, we can use a quantifier at the end of a group. So now we have either AC or DC repeated unlimited times, which might be what we want. So in short, if we have a question mark here at the beginning of a group, it will mean that there are special things going on with the group. And in a way, this brings us to the next and last building block. This is anchors and asserts. And we have here the possibility to either have some predefined anchors like the hat or the dollar that you probably have seen somewhere, which aligns to the first and the last thing in your match, usually on a line. This is, again, configuration specific. Then there are like predefined classes, also predefined, I would call them anchors, but it might depend. They work a bit like asserts too, which matches at the end of a word. But again, pay attention, those are less standardized than those. Then we have asserts, and asserts are now really powerful because you can say, okay, I don't want to include this in my match, but afterwards, like, don't know, I want to have this slash, and directly after the slash, there should be DC. And well, the DC you don't want to replace, but don't know, you want to replace the slash by a dash or whatsoever for reasons I don't know. Or you can say, okay, there's no AC following it. Or there's an AC in front of it, or there's no DC in front of it. My mentor asked me when I presented this slide whether I have to follow directly with this slash, and yes, this is the case. If you want to have the DC 2 characters away or whatever because you have a space in it, then you will have to include the space here or move this after you match the space there, because it matches just there where you write it. And that's probably the building blocks of regular expressions. It's a very small tool case if you want to have it, but it's quite powerful right now. I didn't introduce you to all things that there are in regular expressions. Especially I skipped recursiveness. This is sometimes implemented as an extension, but I think that's most useful. I try to focus on common usage here, so I think it's what you need. Be aware that it's easier to write regular expression than to read it. if you ever came across formulas in LaTeX, it's even worse. But yeah, also be aware of the context. Usually if I say \w is the predefined class in regular expressions, it could be that you need to write another backslash in front of the backslash before the W, because you're writing this in a string inside your programming language. So be aware of it. And well, we're doing some programming, so probably test it and don't give up. If you're using Microsoft or JetBrains editor, it's quite likely that you're having in your search and replace fields this little .* symbol or icon somewhere, which enables regular expression right in your editor for search or replace. If you're using something like Notepad++, we have this regular expression in the search mode field. Obviously, there are many more editors which supports this. Here you can also see we have this option if the dot matches the new line quite prominent. In others, this is, I think, like M as an option or so. It's a bit more hidden. You can use this obviously from code, so don't know, PowerShell has this built in. The \replace operator, for example, uses regular expressions. We don't have to escape our backslashes here, which is quite nice. On the other hand, if you're doing the very same replace in C#, with the same input string, same replacement being done, you see every backslash now is twice, because the string inside C# will eat the first backslash, only the second backslash will arrive in my regular expression editor. Also a nice thing here, you can see PowerShell allows you to find with regular expressions inside folders very easily. And if you wanted to do the very same thing in C#, it's probably something like this, which is like 3 lines more. And yeah, I think this is also quite interesting to see. So we are in a data conference, I guess. So I very disheartened that T-SQL does lack regular expressions built in right now. But if you, for whatever reason, have MySQL or Postgre or whatever, I think even Oracle at your site too, you might be able to find regular expression support in there. I couldn't do the file demo here, so I opted for another one. But the first one is, again, the same replacement of changing the domain of the user from Contoso to Fabrica. So let's see some regular expressions then. One of the more common tasks is input validation. And well, if this was an in-person session, I probably would now ask you if anyone could come up with a regular expression that matches a 6-digit hex string. Don't know. Should we do this, or should I just tell you? I mean, I already offered you all the ingredients, and it should be that you derive at something like that. So we're matching the full string. We start at the start, we end at the end, and we're having a hex digit 6 times. Should be okay right now, right? So names are made of 2 parts with a space in between. I'm having a dagger here because, well, names are made of 2 parts is already quite, well, an assumption. Different languages, different rules, remember. And yeah, well, you could do this like this. You say there is a non-space letter followed by a space, and then there are non-space letters again. We have 2 capture groups, one for the first name, one for the second name, and we could do this. But I probably would recommend thinking whether you really have to check this, because it will probably mean that people will send you in ID cards because their name doesn't match this pattern. And then there's fun stuff you can do with regular expressions as well. Like A is repeated an unprimed number of times. So remember when I said that you can refer to capture groups later? Well, we can do this actually to do some prime number computation here. So we have at least 2 A's, match as few as we can get, and then see if we have the same group again. So I'm using ++ here because then if this doesn't match, we're back to matching another A. And this will match 3 A's. This will match 4 A's, because then we have 2 A's here, and 1 A in the repeating, or 6 A's because we can repeat 2 A's 2 times, and so on. I don't know whether this is useful for you anytime. I saw this in Code Golf, and I wanted to use this as an example for the power that is inherited to regular expression. And then there are those seemingly simple cases like, oh, I want to validate if it's a valid email address. Did any one of you ever dive into the RFC for email addresses? Do you know how IDN really messed up domain names? Like, I don't know which domain names are valid today currently, because I know Berlin now has their own TDL. I know Cologne has their own TDL, but I don't know which TDLs are introduced tomorrow. And then I don't know which local characters are valid for those DNS names and so on. So there is an implementation of this regular expression. You can find it here. I will show you in a minute, but I don't recommend it using it. So let's switch over to demos. I prepared some cases I wanted to show you. I will do this in Azure Data Studio because, well, I'm using a Mac currently, and this is cross-platform, a very nice tool that you probably are aware of. Oh, sorry. I'm switching back once. The URL down here also includes this demo, so if you're now afraid that you will miss something, you can just hook this up. I will show you the slide again in a minute, then you can follow there. Those are the input validation examples. Oh yeah, I can show you this unprimeness also. We have this in a demo over, yeah. I checked it was open, but I didn't remember which one. Oh, this is quotation. So you can see here I can write some input strings, and all those that are blue, those are those matched. And you can see the green one is actually the group that is matched, and this is the repetition of the group that was matched. So I can really match unprime sequences of A's if I need this for whatever reason. I probably don't need this. Okay, and there is this nice pattern I already mentioned that will validate email addresses. And well, I can just follow the recommendation of the one that posted this on Stack Overflow, probably just to check if there is an ad inside, and then send an email. Then you're really sure that it is a working email and not just something that looks like an email. Like, don't know. You can make up email addresses quite easily, I guess. Okay, editor demos. More interesting, hopefully. So one thing that I came across mostly in text that I write is that for some reason, whatever, in pasting, I have two spaces following each other. And now, whoops, don't double click, remember. Now I can just use this and find all those sequences with more than one space right after each other, and go here, replace this by a single space, hit replace all, and they're all gone. Now, well, those were formatting spaces, but it's something that can be quite handy if you do this to a selection. Other thing. In the first block, I have introduced multiple references to the table dbo.tbl. So problem is that with DBO schema, you can or cannot write the schema name, and you can quote or not quote the schema name and the table name. So this is an opportunity to write a good regular expression. So we start by not having a word character because we want to match full words. Then we have either DBO quoted with a dot, or DBO without quotes and a dot, or no dot at all. This says there's no dot in front of me, right? And then we follow this by either table quoted or table not quoted and no word letter. And this brings us to these nice matches. If I would leave out the last part, for example, I would get another match for table 2 here, but well, I didn't want to have it because it's table 2. So you can have much of the same if you just do it like this, where you have the quotations one by one enabled or disabled. I can't use referencing of groups because they will match as they were matched. So if I'm matching an opening brace, I will match another opening brace, but I need to match a closing one. So This will often do what is needed, but this is really what you can do if you want to be accurate. There are other fun things that you may want to do. Don't know, any one of you probably have bad named procedures. Like, for example, you may have procedures that are named sp underscore. Current recommendations say you don't use sp underscore because that's reserved for system procedures. And so you can probably just use this and search for the create statement, replace it by a drop statement, and rename procedure like that one. So I'm dropping my old sp underscore procedure, and I'm creating a new one without the sp underscore, just by defining the right groups here and doing a replacement. Obviously, regular expressions are also supported with find in files in Azure Data Studio. So this might clean up all your SQL scripts in a nice, easy move, and not having you do copy and paste, forget to replace the procedure name somewhere, or whatever. Like, copy and paste is really a great tool, but yeah, well, you mess it up. At least I do. Quite frequently also. Probably a not so nice thing, but well, depending on your script, something you might want to do once or twice. There are things like I might have an update and I need to rewrite this before the rollout to be an insert instead, because the production system isn't aware there is any of those data that I could update. So another thing I can do, I now need to match these statements as they are. This is because this is why this is not as flexible, because I want to transform this, and now I can define those value and those ID matching groups and transform them into the values statement here. One thing that is sadly beyond regular expression is finding all the comments that might be in T-SQL. This is because you can nest block comments in T-SQL. So we have the problem here that we would need recursion, and recursion just isn't really supported in regular expressions, at least not in the default, and the extensions also have their, well, I don't use them. Let's keep it at that. If you know, okay, we don't have nested comments, you still might end up matching things that are really inside strings. This is another problem of regular expression. You don't have context. You may have this if you're using a JetBrains editor, where you can select here that you only match inside strings or whatever, but usually you don't have context. So this means you really have to be sure that your match is either also valid when it would be inside a comment or inside a string, or that it couldn't match in a string or a comment in either way. So if we want to use to match comments, we still can use a bit of regular expression to build a tokenizer, and in the end we need to have a parser that now matches comments. And this is the shortest I can think of. I guess it can be a bit shorter, but yeah. So another thing that happened to me, I wanted to normalize line endings. I can do this with plain SQL, and it uses 3 replaces because I want to end up with carriage return line feed, the Windows new line. So I first replace carriage return line feed by just line feed, then just carriage return by line feed, and then I expand back line feed to carriage return line feed. If I would leave out the first replacement, I would have 2 carriage returns and a line feed if it was already correct. If I would leave out this one, I probably wouldn't catch MAC line feeds, which would probably be more okay. But in the end, I'm doing at least 2 replace turns, and would change every string because I'm first converting the correct line ending to a wrong one to later expand it back again. In C# I can do this the very same way. I could also write a loop that does this, which is even more nasty, because now I need to keep track probably if the last was a carriage return or not. But at least I'm just doing 1 append loop and not 2 replaces. Or I could just do regular expressions. So now I'm having carriage return or not, followed by a new line, or just a carriage return. And this already matches all variants there are of new lines. And I can then replace them with carriage return new line. Done. One replacement. I'm not doing anything I didn't want to, and I'm done. Or you could do this a bit more complex statement, which matches new lines that aren't prefixed by carriage return, or carriage return that aren't postfixed by a new line, and not replace the already correct line endings, and just replace the bad ones. So now I'm having a replace like this in my C# code, which is a lot less load and lot less lines of code, at least. I think this is the demos I wanted to show you. I think I'm also talking a bit faster than in my last rehearsal. I'm sorry. Yeah. So I'm already on the summary, but this means we're having more time to answer questions. So to summarize, regular expressions are very flexible and very powerful. Sadly, right now, MS SQL lacks native regex, but well, you can add it by CLR, like whatever, SQL Sharp or some things like that. Those include regular expression support. It's easier to write than to read them. You should test them because of that. And sometimes regular expressions is the right tool and sometimes it's not. So please provide feedback. I'm here to answer your questions. Yeah, that's what I wanted to show.
Terrific. So we haven't had stuff come into the Q&A box yet, but there is still time for folks to add things into the Q&A box. It will not let me add my questions into the Q&A box because I'm a panelist, so I just get to ask you. I do love your how to regex GIF here. My question is, how do you recommend people get started after this session? Like, let's say they're pretty new to regular expressions. What are the types of things that you would have them do to build upon this and learn?
It's quite interesting. Usually when I'm in like, okay, I need to change this 15 times or so, then I'm thinking like, okay, do I really need to copy paste this, or could I do this by regular expression find and replace? And this is usually the thought I'm doing. And if you're not well aware of what you're doing with regular expressions, the website I already showed you with the A's is a quite handy tool, because for one, it will try to explain what your regular expression tries to do. So you see here the different colorings, they are taken over here as well. You get up the full details of what you did match, and you can even write unit tests for your regular expressions. So if you, yes, so if you're not certain that you're doing what you think you're doing, this is a nice playing ground to do. You can also change between regular expression flavors here quite easily. So you can just switch to a different style of regular expression and see whether a regular expression would still work or not. It's quite handy.
Great. A similar question has just come in. Thank you, Abdul. And it is a question about, can we know how to practice regular examples and any websites, for example, that have material and examples? I also tend to learn really well by example. Like, that often helps me as well. So this is a great tool that you're sharing here. Any other thoughts about helpful sites for getting started?
It's often interesting to really go into the documentation. For example, if you look up the replace operator for PowerShell, you immediately have 5 examples on how you could do replaces in PowerShell. And this might be a first starting point on seeing how you do find and replace in this very language you're doing. Remember, it's like 90% is standard, the rest is dependent on your implementation. So in the end, it might be a good idea to have a short visit at least if you're using a more complex thing. Don't know, there are different ways to get into it. Sometimes also asking your colleague or me or whatever might be a good way of getting into regular expressions. I'm not sure. Like most companies use regular expressions if they are aware of or not in some part of their working.
Yeah. Is there, so for example, sometimes I use Twitter and there's like a SQL help hashtag people can use on Twitter to ask questions about SQL. I I'm asking a question where I really don't know the answer. Are there community or sites online that are especially good? Do you know? Is Stack Overflow the best place to ask a question?
I
or
have
are there
some
other
Stack
options?
Overflow questions, for example, with this address regex, where I got this from. And you can obviously use this. You can also see why D is less efficient because, well, it's matching Unicode numbers. Like those are numbers according to \D, probably not numbers according to me, but yes, Unicode defines those as numbers as well. And this is really interesting if you have a specific question. But on the same side, it might be enough if you have followers to even use SQL help. I'm not sure. I'm not aware of a regular expression help tag. Probably we should build one and have somebody answer that.
Yeah, just looking at the vote counts on those answers, it does look like quite a lot of people use this on Stack Overflow.
Yeah, regular expression tend to raise questions, it seems. So this is also why I wanted to do an introduction, because I really think that the basic principles are quite easy. So if you're downloading my session, which you're probably doing or looking at it afterwards, remember those building blocks, and I try to include in the graphic the basic form of the things you're doing. Like you're having brackets here, no commas, you're doing a class, which is on the same line here. You're having quantifiers, which you can do with this comma, and the curly braces, and anchors and asserts, well, just down here, groups would be here. Well, it's not perfectly aligned. I can do better next time, probably.
Yeah. Oh, and I should say, other panelists, if you would like to unmute and chat and or turn your video on, you totally can as well. So for example, Beardy McBeardface, you just shared a wonderful resource in the chat, which I'll recap, but if you want to talk about it yourself, you totally can too. Beardy McBeardface has shared that there's some really good PowerShell European conference videos on regex that you can get to on YouTube.
Yeah, I have a comment on that, on the website that you just opened.
Yes.
There is the flavor of the regex.
Yes.
Which is due to, as you mentioned in your talk, it being slightly different for each language, yes, and some interpreting stuff differently. I'm strongly missing .NET here.
Yes, I'm sorry.
Yeah, that's not your fault. I'm assuming this is not your homepage. If it's your homepage, please change it. If it's not your homepage, then it's not your fault, so you don't need to.
No, .NET is quite similar to PCRE. It's like, yes, 90% similar. I would go for PCRE.
And the 10% are those that tend to hurt me.
Yes, I know. I can send you over to this nice regular expression language quick.
I know, reference. But writing and learning with a tester is much easier in my experience. There is one tester for .NET, and it's regexhero.net.
Regexhero?
But don't open it now, because there's a caveat here. And the caveat is this page is ancient and works with Internet Explorer version, I don't know what. And I've not gotten it to work with Chrome, for example. But if you're on a Windows PC and you need to learn regular expressions, regexhero.net works for me in Internet Explorer.
There are other sites that can test regular expressions. Now I found this only when looking up things for the session. I know if you're not using the .NET tools, but regular tools from JetBrains, you even have some context action to see what your regular expression is doing, which I really find nice. And I guess there are other tools and integrations that will get you where you want to. And in the end, do make up some examples, see if they match correctly, even with your code, because in the end, maybe your calling introduces another problem, because for whatever reason, you missed another backslash that you should have introduced here whatsoever.
How about
can I just have a quick follow-up question for Mr. Kettner? So,
sorry, gotta go.
Weren't you the one who was, oh, I love LaTeX so much, and now you're complaining about an ancient website, really? I mean, the irony doesn't get lost on that.
I'm glad you realized it.
Sorry, Beardy. Go ahead.
No, it's perfectly okay. It's your conference. You're allowed to interrupt whenever you like, my gorgeous man.
And you're just telling me that now?
Of course. I was going to ask about performance gotchas.
Yes, the more complex the regular expression gets, the more performance it will probably cost. So when I pointed out that there are those special things with quantifiers, like for example, you can add those question mark or plus signs, those can make a big difference in performance. If you really know there are difficult texts to match and I match them often, try to think whether it really is a rather long match or if there might be something that follows that could even match. Like if the next char here would be a B, you're sure that releasing an A will not match a B. So tell the parser you don't need to give back any A's because there would be a B expected. Things like that will improve performance. I already said that sadly regular expressions are not indexable. So you have to execute this match for every line that you want to match. This is another probably not so nice thing in performance. I guess it's not so much worse than like for that bit though. And yeah, well, in the end, you have to see whether performance is good enough or not. Like usually I never had performance problems, but that also probably meant that either the load was low enough or the machine was big enough. I would say you have to test it.
Yeah, and also I think something that should always be mentioned is the greediness of regular expressions. You've mentioned that a few times, and I think that's really important. Yes. Because that also means if you have a dot in there, and especially dot star, it will just continue matching.
Yes,
as much as possible, no matter what you put behind it.
It's a common thing, but probably not a useful common thing. Like if I'm doing this here, now I'm probably having the problem. Okay, I was smart enough to hinder this, but a common caveat that you have is if you want to match a single string or whatsoever, and just doing dot star another quote, you're probably matching the start of the first string and the end of another string because you're matching everything in between with a dot, and the dot matches everything but a line break. Right? So you're matching almost everything. So either use a less big group or some assert, like for example here, I want to match everything except quotes, which might help, and then you can have the match you're looking for.
Yeah. Only this greediness tends to be something that I trip over when starting to write regular expressions again.
If you're writing dot star, think about whether you really wanted dot star question mark, because usually it's the more correct version.
Yes, and that's the most important hint anyone in this session will ever get on regular expressions. Think if dot star is really what you need. No, that's really important. I'm glad that you said that.
Yeah. It's also quite interesting. If you look at the symbol, it's dot star, but dot star probably isn't the best thing of regular expression. It's just one common thing of regular expression.
Yeah.
And for those who are still here, it's not too late to add your questions to the Q&A panel. We still have one in there that I don't think we've covered. Correct me if I'm wrong. This is from Beardy McBeardface. Which version of regex tester is best for PowerShell? And then there's a winky face after this question, so I'm not sure if I'm falling for some sort of joke I don't understand here.
I think PowerShell has the same test constraints as .NET, so in a way we already answered this.
Yes.
That we're unaware of good testers for that. So I give you all the homework. You write a regular expression tester for .NET. I will rate the results on Monday.
If you could just do that, that would be great.
Challenge accepted. So Matthias, when do we start?
You can start right now.
No, we. As in you and I.
It's a trap.
So the one that I use is regex storm.
Regex storm?
Yeah, regexstorm.net. And that's I think it's /tester.
Yeah, also I've missed an X. I guess it's important.
With an X as well, yeah. That gets me past most of my problems with regex and PowerShell, because it's focused on .NET, but The reason for the winky face, Kendra, is that you can put a set of regex in and some input into one of the other ones, and it will work perfectly. And then you put it into PowerShell, and it just will not. So it's a common issue, and I myself still fall for it.
I just well, cheated, so to say. I copied the regular expression from here, which I think is as complex as it might get for most regular expressions. It already uses features I don't use on a daily basis when using regular expressions. And it perfectly well translates to PowerShell. And this is something that I really find interesting, that PowerShell, besides not being standardized so well, is quite standardized.